Hey! Thank you for joining Kevin, James, and I for Sense, Analyze, and Generate Insight with Real-Time Analytics at Build. Let's start with some context. In the last 25 years, there has been a revolution in the way that we consume our content in our personal life. The evolution in technology leads to new habits of interactive experiences on demand whenever we want it, whenever we need it, without any barriers, and everyone can ask questions without any limitation, from my 6-year-old son to my parents. And the technology behind this revolution is accessible for everyone, with data set that can store any type of data at any scale, get updates in streaming with few seconds of latency. All the information is indexed and partitioned, which allows us, the user, to ask any questions without pre-planning and get the results immediately. And everything is ramped up with a very intuitive user experience. But in the enterprise world, there are still rely on few experts to generate reports, to write their queries, and to ask their questions. All the other people in the organization has a strong dependencies on those experts, with long waiting lists and outdated data. And the answer for that in the enterprise world is Fabric Real-Time Analytics. Fabric, as you already know, is a SaaS data and AI portfolio. All the experiences are fully integrated with one logical copy. One logical copy means that once you bring the data one time, it's accessible to all the experiences to run processes and action without additional effort. And specific in real-time analytics, there is the streaming capability that provides the information into Fabric in a couple of seconds of latency from ingestion to query, and everything is indexed and partitioned, including structured data, semi-structured like JSON and arrays, and also free text like chats. And once everything is partitioned and indexed, you can ask any question by everyone in the organization and get results in sub-seconds. And also, real-time analytics is fully integrated with the other experiences, so you can run also notebook and other experiences on top of this information because it's accessible for everyone with the one logical copy. With Fabric Real-Time Analytics solution, organization can consume torrents of data, unlimited scale up their work with storage, CPU, number of queries, and number of users. On data in motion to empower business analysts, to enable data to everyone at the organization, from the citizen data scientist to the advanced data engineer. And the most common scenario for real-time analytics is time-based experiences like IoT event and log analytics, including but not only gas and oil, automotive, cyber and security, smart cities, manufacturing, and many, many more. This is the most common usage pattern. Get data from any source, ingest it with event stream into KQL database. With one logical copy, the data is available also to the other experiences like data warehouse and lakehouse, and we can consume it with Power BI report, with notebook, and of course with KQL query set. Now, let's move directly to see an end-to-end demo together with Kevin and James. And the COO of a taxi company in New York City, Daphne, is interested in a better understanding the use and defining opportunities to utilizing. Her understanding is that she will need to collect all rights at the beginning and run questions on the data that she will gather. So the first thing that she will need to do is to create a KQL database. This is an analytic database that can scale up to exabytes of data and thousands of queries and users. It can support structured data, semi-structured, and free text. Everything is indexed and partitioned, allowing Daphne to run any query and get fresh results immediately. The first thing that we need to do is to connect the writes into this database with event stream. Kevin.
Thanks, Tzvia. Event Streams provides the ability to ingest, transform, and route millions of incoming events in real time using a simple no-code designer. That data can be change data capture events, telemetry data, clickstream events, IoT data, and plethora of other event sources that are constantly being generated all around us. Let's create a new event stream. We'll call it Taxi Event Stream. After the event stream is created, you are taken to the no-code canvas. You would first start by adding an event stream source. Here you can see you have a number of source options. A custom app source creates an endpoint that allows clients using the Kafka API, for example, to send events directly to this event stream. Azure Event Hub's source will consume events in real time from an existing Azure Event Hub. Sample Data Source allows you to choose from various samples datasets that allows you to quickly leverage and test your event stream. Let's select Sample Data. In the sample source, you can select from either Yellow Taxi Ride events or Stock Market events. Let's select the Yellow Taxi sample data. This will continuously ingest Yellow Taxi event data. Let's call the source Taxi Sample Events and click Create. Selecting the Data Preview tab allows you to preview the incoming events into the stream where we can see the sample data flowing into the stream. Now let's add a destination. A custom app destination provides an endpoint where a Kafka client, for example, can consume the events from this event stream. You can also route the events into a lakehouse table, or you can route the events to a KQL database. Let's take a look at the lakehouse destination. Sending events to a lakehouse will automatically convert the events into Delta Lake format. Let's give the destination a name, select the workspace, select the lakehouse, and enter in the table name where I want to route the events to. You can then choose to add an event stream processor. This will create a no-code stream processor that can filter, transform, and aggregate events before landing into your lakehouse table. This transformation and filtering can eliminate the need to store extra copies of your data in bronze format if you're used to thinking in medallion architectures and data warehousing. I can change the type of incoming fields. I will change the trip distance from a string to a float. I can also only select the columns and with the names that I want to use in my lakehouse. You can also add different operators to manipulate the incoming stream, such as aggregate, which allows you to create time windows with summations, counts, averages, min or max, for example. Group by, which provides merging or windowing over time. Manage fields, which lets you do rich transformations with built-in functions. Let's select filter. We'll only include taxi rides that were greater than 5 miles. We will now click Done, and then we'll finish creating the destination. Now let's send the data to a KQL database. The KQL database destination provides high throughput consumption and automatic indexing of all the incoming events for fast querying. Let's give it a name, select the workspace, and the Taxi Rides Demo KQL database, and we'll use Taxi Rides table. We'll then go through a short wizard to configure the ingestion. We can see a preview of what the data will look like as we ingest the stream into the KQL database. Selecting Data Insights provides monitoring insights for the health of your incoming event stream, where you can determine if there are any bottlenecks. You can see all of the yellow taxi data landing in a KQL database. I will now hand it off to Tzvia, who will walk you through the capabilities of the KQL database.
Thank you, Kevin, for connecting the taxi rides into this table. Using the KQL database, Daphne will be able to connect her stream of rides with a couple of seconds latency, and all the information will be immediately available for queries with a fast query response time. Now, she would like to upload the local files with information about the drivers to help her to run better queries in the future. She can ingest data from different sources and different structure, different formats, whether it's for OneLake, Azure Storage, Amazon S3. She can just select it from her own computer. At the background, there is an inference that infers the most appropriate schema for this source type. She can keep it as it is, or she can make adjustment with the database or the table structure. She can define whether she would like to use dynamic columns from JSON with properties that will allow her later to easily change the schema of the table without changing the table structure, meaning that she can put different formats, different structure into one table without updated structure. Or she can just change the nested level and get it as a structured data. Now we are creating the table, ingesting the data, and we have new table with new information. This is the database editor, one location to manage and control KQL databases. Everything is available with simple user experience and fast response time. I can get into the list of tables to a specific tables to see the size, the schema. I can manage the database. I can manage the table. And I can start and run queries on top of it. I can select to run one of the pre-generated queries that are the most useful syntax. I can write my own queries and utilize and leverage the capabilities of this IntelliSense, and to see how the vendors are distributed. And I can also add visualization to make it even simpler for me. And equivalent, in addition, I can run those queries in SQL if I prefer to do it like that. And both of them are supported, the KQL side by side to the SQL. And I can save it as a KQL query set. The KQL query set is the one place to run analytics. I can run complicated analytics or simples. I can share it with my colleagues, with my team members. I can save it to myself for future work. And coming soon, we will add also visualization and Copilot, HV. She has it in one of the lakehouses. So she can just create a shortcut into this database and easily join between the different tables into one unified analysis. I can go here, create a shortcut, select the relevant source to get the information, and immediately, in a couple of seconds, I have a shortcut to the OneLake table, and I can join between the different sources. I just moved to a KQL database that I have created a couple of days ago with high volume of the text-derived stream. You can see that I already collected 420 gigabytes of information, compressed into 100 of gigabytes of data, and it's very efficient from the cost perspective since KQL database store the information as compressed size and not the original size. At this point, I will open one of the KQL queries that I have prepared and start to run the query. First, I would like to understand the size of the data set. I have 1.5 billion of records. I am running to understand the distribution over the day. This is the distribution of the write during the weekdays. Now I would like to see the time series of the 1.5 billion of records. And I can also see that once I'm adding regression analysis on top of this time series, it's easy to see that since January 2014, there is a drop with my company rights. Let's try to understand what is the source for this issue. So I will combine it with FHV table that includes Uber Life's company. And now I can see that the drops come side by side to the increase of the 3 prior rights companies. If I would like to go back and find some anomalies on top of my time series, I can run it and find it. And just think about it. I just ran an anomaly detection over 1.5 billion of records in a couple of seconds. You get the response, and I can easily understand it. I would like to increase the sensitivity. And I can rerun it and get the results fast. Now that I would like to utilize the performance of my drivers, I will find the most important parts of the city to locate my drivers there. We live in a world enterprise companies rely more and more on IoT events and log analytics for cybersecurity, asset tracking, customer experience, marketing campaigns, health, and more. As a result, torrents of data are generated at high scale. KQL database and KQL query set were built to empower enterprises and high-speed scenarios. With unlimited scale in storage, CPU, queries, and number of users, a KQL database can store data of any format, source, or structure. The data is indexed and partitioned, so Daphne and anyone like Daphne can run queries without pre-planning, and the data is available in seconds, and the result can retrieve in sub-seconds or seconds, which contributes to the high freshness, low latency, and high query performance. The data is also available in one lake and data warehouse with one logical copy. If you need one or more of those capabilities, and if you have one of those scenarios, KQL database and KQL query set is the right choice for your enterprise. Now we will move to James to learn how can we make those insights into action.
Thanks, Tzvia. So far, Kevin has shown how event streams can capture, transform, and route event stream data. And Tzvia has shown how we can create real-time insights from that data using KQL databases. Now, I'd like to talk about driving actions from your data. After all, your real-time data is only valuable if you can act on it. This means that once you've generated insights from your data, you need to convert those insights into jobs to be done. And if you're like many organizations, you're achieving this today through manual monitoring of dashboards. Now, continually monitoring a bunch of charts throughout the day can be time-consuming, so perhaps you've considered coding up an automated monitoring solution. But coding can be relatively slow and expensive, and the cost involved is often just not worth it. That's why, with Fabric Real-Time Analytics, we've envisaged a brand new solution for driving actions from data. A solution that empowers the business analyst to detect actionable patterns in data and automatically convert those patterns into actions without the need for writing code. We call our solution Data Activator. Here's how it works. Data Activator connects to any data source within Fabric. It can bring in real-time streaming data from event hubs and run queries on your KQL databases. It's not limited to real-time data though. You can connect to slower-moving data in warehouses and Power BI datasets too. Then, Data Activator gives the business analyst a no-code tool for defining triggers on that data. the business analyst tells Data Activator which patterns to detect. Then, when Data Activator detects those patterns, it triggers an action. Now, that action can be as simple as sending an email or a Teams message to the relevant person in your organization, or it could be triggering a Power Automate flow or driving an action in one of your line of business apps. Regardless of the data source, and regardless of the action system, Data Activator gives the business analyst a dedicated place to define their triggers and a consistent, no-code experience across all of these different data sources and systems. So, without further ado, let me show you Data Activator in action.
Okay, so I've opened up Data Activator. You might remember that Tzvia concluded her demo with a KQL query and a chart that showed the number of taxi passengers waiting for a ride per neighborhood. I've connected Data Activator to that KQL query, and Data Activator is now bringing in those query results in real time. So what I get is an event stream generated from that KQL query that gives me a continual feed of the number of passengers currently waiting for a ride in each New York neighborhood. Let's suppose that a taxi administrator wants to get an alert if there are too many passengers waiting for a ride in any neighborhood. That way, the administrator can direct idle drivers to head towards that neighborhood. Let's have a look at how the administrator can do that. Now, the first step is to create a Data Activator object. We want to track the number of waiting passengers per neighborhood. So to do that, I want to create a neighborhood object keyed off the neighborhood name. So I do that, and I flip across to design mode where I can see my new neighborhood object. The next step is to add a property to that neighborhood object, which is the number of waiting passengers for that neighborhood. I'll give it a name, waiting passenger count. And now the next step is to associate a value with that property. What I want to do is to associate it with the number of waiting passengers column in my event stream. So I picked the number of waiting passengers column. And straight away, Data Activator gives me a chart showing the number of passengers waiting for a taxi over time per New York neighborhood. Now, what I want to do is to create an alert if the number of passengers crosses above a threshold. I'm going to pick 10 as my threshold. And finally, what I want to do is to tell Data Activator to send an email if that threshold gets crossed for any neighborhood. Let's give that email a meaningful subject and a headline. Great. And now the final step is to hit start on my trigger. As soon as I hit start, that's going to activate my trigger, and Data Activator should start sending me an email whenever the number of passengers waiting for a ride in any given neighborhood exceeds my threshold of 10. Let's head over to Outlook to see if we're getting any emails. And opening up my Outlook, I can see that I've already received an email warning that there are more than 10 people waiting for a ride in the Soho neighborhood. Terrific. So in just a couple of minutes, I've been able to convert a real-time streaming data feed into actionable email alerts using a simple no-code experience. As a final step, I'll show you how to build a Data Activator trigger from a Power BI report. Here's a Power BI report that shows search activity for our taxi company. The taxi administrator wants an alert if there are too many unsuccessful ride searches in any neighborhood. So I'll filter the report to show unsuccessful ride searches. Next, I click Trigger Action on a visual to begin creating a Data Activator trigger. Now I'll set up a trigger that checks every hour for each neighborhood if there are more than 10 unsuccessful ride searches per neighborhood. And we're done.
And as we continue to build out Data Activator, we'll be expanding it to include more types of data from Fabric. We'll also be expanding it to detect not just threshold conditions, but many types of patterns over time. All this will be accessible through that simple no-code experience that you've just seen. Now, Data Activator is currently in preview, so if you like what you saw today, I'd encourage you to sign up for the preview. You can do that by visiting the link that you can see on the screen right now. We'd love to hear from you. Thanks very much, and I'll now hand back to Tzvia to wrap up.
Thank you, Kevin and James. I enjoyed the demo so much, and I hope that you enjoy it as well. With Fabric Real-Time Analytics brings technology evolution into enterprises. We will be able to have interactive experiences whenever we want, whatever we need. Without the barriers, without to rely on experts, we will be independent. We will have the ability to ask any type of question on our data and get immediate response, and answers. So if you would like to hear more, you are more than welcome to meet with us in person at the Expert Zone. And in the meanwhile, thank you for joining us and enjoy the rest of the event.